Hello everyone. So this presentation is about the detection of criminally convicted email users by behavioral dissimilarity. Authors are Maqsood Muhammad, Pranav Kumar Pathak, Vaishali Bahin Pathak and Zahra Afridi. Presenter Pranav Pathak. Okay. So this is the contents. These are the contents which we will cover during this presentation: introduction, problem statement, related work. After that we will take our proposed system, which is having the 15 feature selections. We will also describe those 15 features. After that we will take mud architecture. Then we will compare the results, and the discussion will be there. Then conclusion and the reference will be taken. So charismatic prevailing of a social networks in our society, like a spider net in our busy life schedules. There are some social websites, for example Facebook, Twitter and Orkut, etc. Willingly or willingness to provide our personal information and details. We upload everything over there. We upload our photographs, our personal informations on such kind of social websites, right? Our activities on our social networks are just without any hesitation, and we upload all our personal, many personal information on those social websites. It can be used and analyzed by the third party, right? It can be also used by the criminals and the investigation agencies. So what is the solution of such kind of such kind of problem? Well, we can have some existing solution. We can have some early warning system which are based on some principles of retrieving and extracting information available online or offline. We can also have mail servers. For example, some big organization, for example university or some other organization, they are having their own mail servers, and they can keep eye on that. Here informations, and then whatever the received and the sent emails are there, it can be investigated by the third party to find a criminal. Here, for our proposed system, we have applied it on an email network system. We have taken an Enron database, which was bankrupted in the USA. Their email database is freely available on the website. We have used this database and we have analyzed it. We have applied our proposed system on that, and then we have compared it. And what we have found that we can easily find 50% of the criminals on our list. For example, here in the top 20 we have found 3 criminals out of 6. So which is the success ratio is 50%, that we can see that. Let me start with that one. This is a Morgan Stanley chart which shows the 2 graphs, left hand side and right hand side. The green line is for the social networking, and the pink line is for the email. You can see that the left hand side, the global users are going almost very much parallel, while the right hand sides are diverging. So problem statement, let me start with that one. So how to extract the convert link in an email communication network that are either e-criminals, fraudulent persons or scammers, or harm the society ethically and economically and socially. So here we want to find such kind of criminal person, right? For example, the bankrupt Enron company, when we apply this our proposed system over there, we found that at least the three users were there in our list out of the total 6 were detected. So which is a quite good ratio, which is a 50% success ratio. So let me start with this one. Related work. Okay, for related work, Gupta and the Day have proposed Gupta and the Day have proposed an efficient algorithm for anomaly detection from the social networks. Ramaswamy have proposed novel formulations for a distance-based outlier that are based on the distance of the point from its neighbor. Nithi and the Day have proposed an efficient algorithm for anomaly detection from call data records. Zertarpata and Kisporzik have introduced the concept of a multi-criteria weighted graph similarity method. Winston and et al. Have described the initial results on the modeling, detection and tracking of terrorist groups and their intents based on the multimedia data. 7th reference, Vilu M. Tavalai and Gorbani have presented a novel network anomaly detection approach. Kurkowski in a paper 8 have presented a multi-model social networking system. Larson and Vagin have used centrally measures from complex networks to discuss how to destabilize the adversary networks. Negwensky, Hui, Lim, Hartnett and Resnick have provided a review of the work related to the area of dynamic modeling. Or in the 11th reference, authors have presented the framework. Okay, Lean and Chalupovsky have described the novel unsupervised framework. Bhatia and Gaur have presented a newly algorithm which is based on the BFS technique. Hui and Hung Yawan have highlighted about the current modern advanced social networks and its prevailing impact on the society. So let us start with our proposed system. So this is the database set which we have taken. It is online available on this particular website, www.cs.cmu.edu Enron. It is Enron's company's database which was bankrupted, and basically 6 criminals were found, 6 fraudulents were found over here. Fraudulent was found out of 6. What we are doing over here, that we basically this particular notepad database for each email system, we can see that it contains a date, from, subject, to, CC, BC, folder, body, file name, etc., information, the time also, the day also, right? Such most of the all information it covers. We have used this particular database to prove our proposed work. What we are doing in the proposed system, well, we detect anomalous users based on their behavior dissimilarity from others. A rich feature set of 15 features is proposed for our outlier detection. We are detecting outlier over here, and there we are using 15 feature for that. We will describe later on during this presentation about all those 15 features. We have used kth nearest neighborhood algorithm, and we have also used Equus formula. Significant results are shown with the respect to outlier detection, which in return gives a malicious nodes in an email communication network. So the algorithm determines all those entities which are very diverse from their neighbors and therefore is eligible to be outlier. the complex of the algorithm is n square, where the n is the total number of the nodes. Okay, so let us start with the algorithm. First, the step is the select the value for k. Step 2 is for each node determine the distance from its kth closest neighbor using the Euclidean distance, and then as a step 3, organize the data points in the descending order of a distance of 10 in a step 2. And then the last step, the fourth step, is the select the top end points as a outlier. For example, whatever the data we have and of whatever the outlier we found, we will put them in the decreasing order, and we will take the first 20 database from that, and then we will just concentrate on those first 20 database, or the investigation agency can concentrate on those 20, and chances are there that the criminal or the fraudulent can be found from there. For example, we have found the 3 out of the total 6 users in our top 20 database, which we will show it into the furthermore over here during this presentation. So the initial design of the system depends upon the 3 relational schemas. One is user file, message file, and the third one is a user interaction file. User file contains nothing but the user ID, name, and email ID. Message files are containing the number of emails, the meet, subject, size, and date, time, and content. User interaction files, for example, the source user, the dest user, the message goal, comment type, and attachments. We will ignore here the body part of the message. We will just take this characteristics. Okay, so what we have done over here, that we have applied the Euclidean distance formula. We have used also Euclidean distance formula. It was introduced by Euclidean, and it is nothing but the distance between the 2 point x and y in the Euclidean space, where we will take its square, and then each iteration's summations, and we will take a square root of it, and the last we will take a absolute value of it, and we will get this particular distance using this particular formula. Yes, these are the 15 feature which is our proposed work over here. The first feature is the out degree, which is represented by the positive sign. In degree, which is represented by the minus sign over here. In out ratio, out in ratio, ratio variance, message change time. The sixth feature is the message change time. Seventh is the message receive time over here. The eighth is the 8th and 9th are based on the day message sent and message received day. Okay. 10th is the sent message with the attachment. 10th and 11th are for the attachment, you can say that. 12 and 13th are for the message size mean. Okay. And 14 and 15, which are the most important feature, you can say that, which is least contacted user and the least contacting user. This is the main feature which we are using over here. I mean, 14 and 15 are the most important features over here, which we can take a note of it. So let me start with this one now. Okay. Okay, so the first feature is about the mathematical representation of the features. This one is out degree and in degree. out degree is represented by the positive sign, and the in degree is represented by the negative sign over here. We can have the mathematical representation of in degree and the out degree over here. We have used over here nothing but the graph theory. We have two nodes over here, U and V. Basically we can see it over here. In degree means how many emails are receiving, and minus sign is used for that actually. The plus sign is for out degree, and it stands for how many messages are sent, right? So we can see that this one, both are the functions reciprocal. Okay, please take a note of it. And the next is this one, in out ratio and out in ratio. This is the formula which we have used it over here. After that we have it, this one, the ratio variance. Ratio variance is nothing but the difference between the in out ratio and out in ratio. You can say that, yes, RIOU minus the ROI. This formula we have used it over here. After that message send time. Here we can see that it is nothing but the summation of a different iteration, right? Here we are dividing frequencies by time, right? So time divided by frequencies. You can here the time is nothing but the time which we have sent it, and the frequencies stands for the number of emails sent or received. It is based on that. This is for the message sent day and message received day, the same like the previous side, but here we will use the day over here, two variables, ds and the dr over here. The same thing is applicable over here also. We will use over here sent message with attachment and received attachment. Same thing, sent message size mean and the received message size mean. This is its formula over here. Frequency of the sent email and the frequency of the received email. This is nothing but the purpose of this one, this particular formula. Yes, least contacted user and the least contacting user. This is very important. If you are sending only one or two message while receiving more than 80 messages, so this can be, we can put it in the least contacting purpose, while the same thing is applicable. For example, for the least contacted purpose, it means if the difference is very much high, while sending and the receiving message. This is what we are trying to find out over here, basically. Okay, so here is the merge system architecture. Let me start with this one. Yes. Okay. Yes. Merge system architecture. MERS. Yes, MERS stands for malicious user detection system over here. It starts from the bottom. Actually, you can see that over here. It starts from the internet, where the from the internet server we will instruct the emails using the POP and the IMAP system. After that, intermediary stage comes, where the first intermediary stage is a email repository. Yes, and after from the email repository we have to extract the transformation subsystem, and from transformation subsystem there is another intermediary stage which comes called intermediate representation, where how you gonna represent the emails from the email repository. After that you have to make a outlier ranking over here. Basically two things are there. One is the equilibrium distance between the 2 points by KNN algorithm. Yes, you can say that. Now and the second is the outlier ranking, which is by sorting a data in the descending order. The sample we will show it during this presentation. And here for the outlier ranking system, by sorting a data, what we will do is we will put them in the descending order, and the highest distance will be on the top and the lowest distance will be on the bottom, so that the lower part, outlier ranking, is the final step. After that we have to show the result to the person who will see for the anomalies. And after that the implementation of KNN using our fifth feature, we will get into this data. Let me start with this one. Yes, so this is exactly the thing which I was talking about. We can see over here that basically we have the top 20 database over here. After applying our proposed system, we got this particular the top 20 users over here. Here we have 2 points, point P1 and point 2, and basically the distance over between them is this one, 9634.455078, and then the point P1 to point 8, these are the distance. Here we can say that in the yellow, this 3 were the criminals found, fraudulent found, and with this particular Silly, Richard, and the 19th position, the John. These three are these three were the criminal out of the total 6 criminals. So in our database you can see that out of 20 out of 6 we got these 3 users, these 3 criminal in our list. So our success ratio is the 50%, that you can see it over here. Of course the distance over here is 9634.455078 for the first one. Second one, Silly to Taffy, we have distance 4513056641, and so on. So it is in the this one, the decreasing order. We can see it over here. Okay, so here this is what we have found. This is what we have found, the outlier over here, and in this outlier system we have found these 3 criminals over here. So what is the conclusion? Well, outlier were successfully found out by using the KNN algorithm. Feature were thoughtfully chosen to meet the requirements of the outlier detections and hence finding the malicious user. These results can be used further for analysis of the more complex on the social network. We have choose just email system over here, but we can apply the same funda on the some social network website like Facebook, LinkedIn, or Twitter, or Orkut, etc. Partition based algorithm can be used in case of very large social networks. Contents analysis for email body can also address in the future to give a more strengthened results of a malicious user with the proof from the text rather than the behavior analysis. These are the references. You can see it over here, and more references over here. And thank you so much for listening. Let me know if there are any questions regarding this proposed work. Thank you so much, appreciate it. This was Pranav Pathak as a presenter. Thank you.